Hey everybody, it's me again, Rich Andre, and today we're going to be talking about the van der Waals equation. Okay, so let me just get rid of this. Okay, so we're going to be talking about the van der Waals equation. And what is the van der Waals equation basically? It's basically just sort of like a modified version of the ideal gas law, but you're kind of using it for different reasons. Okay, so those different reasons because you have to take account the non-ideal gases. Okay, so if you're taking into account ideal gases in the ideal gas law, uh, basically just gases that have no molecular forces between them. Okay, no intermolecular forces between them. Okay, now you're taking into account those sort of like intermolecular forces in van der Waals equation. Equation. So the van der Waals equation looks something like this, but it can vary. Okay, depending on what source you get the formula from. But this is basically just what it is. Okay, so this is the pressure, and this is the moles squared of some constant. Okay, and these two constants are basically those intermolecular forces, those attractive or repulsive forces that happen basically okay in any atom. Okay, or in any gas. Okay, I mean gas. Okay. So this is pressure, this is volume, this is volume as well. Then there's some constant, it's the moles, and then this is moles, and then this is the ideal gas constant, which is 0.08205, 0.08205 liters mole, and uh, atmosphere in K. I mean, I know it's atmosphere in K. No, actually, this is incorrect. The ideal gas constant is L, ATM, atmosphere, and then we have mole and K. Okay, so and this is going to be temperature. Of course, the temperature is going to be okay in Kelvin. In Kelvin. So let's solve some equations. Okay, first let's solve this first problem. Let me just screenshot it. All right, and then I'll paste it there. Let me just get the screenshot. Here we go. Okay. So using this formula, we have to solve this for the gas. The gas envelope contains 1 mole, and then with a 10 liter container at 300 Kelvin. Okay, so we have to get the pressure. And in order to get the pressure, we basically use this formula. Okay, we basically use this formula right here, which is I believe n squared a over v squared minus v. I mean nRT over v minus nv. Okay, so it's going to be the formula that we're going to use. Let me just recheck if that's correct or not. Okay. Okay. That's correct, but the order is wrong. This is actually going to be the one in the right side here. Oh. Be the one in the right side. Yeah, to minus that here. We have P equals, yeah, so substitute the numbers. We have N, what is the mole? That's 1.0 mole. Oh wait, no. So that's going to be 0.0318 times the oh, that's actually the B gas B. So this is actually 1.00 times the ideal gas constant, which is 0.08205 liters, and ATM over mole and K, and then times T, which is temperature, and the temperature is 300K. So over V, which is volume. Okay, so we have 10 liters right here, 10.0 liters. Minus NB. So N is going to be okay. V minus NB, which is, I believe, so we're using 0.0318. Wait. Let me just try this first. Then I'll figure out where we got wrong. Afterwards, if we are wrong, 318 L slash mole minus N is L squared, which is 1.36 L squared at ATM mole. So we're trying to find the pressure. So obviously what's going to come out is atmosphere, which is the standard pressure. Van der Waals, we're going to V squared. What is V squared? It's going to be 10.0 L squared. So let's try to use decimals for this. Decimals, yes. Scientific calculator right here. And then I'll try 0.08205. Times 300. Hold on, 300 over 10.0 minus 0.0318. Just remove this. Let me check if I'm right. Then I'll just correct it if I'm wrong. Minus 13.6. 7.6, right? 13.6 over 13.6 over 10.0. And the answer is going to be 1.0, about 1.11. About 1.11. Okay, so the answer is 2.43, so I'm going to check where I got it wrong. I'm going to check where I got it wrong. Since it's n times b, I think you're supposed to times the mole. Trying to get the pressure here, so. Okay, so they just use 0.0821, that's why. 0.082. Oh, okay, okay. 821. 0.0821, then 0.038. Oh, I got it wrong. It's actually 1 point. 1 point. Okay, it's 1 point here. 1.36 liters. Actually, 1.36 liters. So mass is going to be 2.34. So I got it right. 2.34. Wait. No, I got it wrong again. 2.33 minus. It's just here 2.43. 10.0 liters minus 0.0318. You're supposed to times it with a 1 squared, yes. I think supposed to time it with a times it with a 1 squared. 1 squared times, yeah. Then you're going to times this. Squared, you have to square this. Is that way? One times. Hold on. Oh my goodness. You're supposed to. Just so I got it wrong. Maybe I need to learn this actually first. Stay insane. Can you work it? Yeah, man, just as soon as your shit is over. I've been waiting. I can't sleep. Reminiscing, missing about you. Oh, and we break. So anxious. Yeah, could you quit that? Oh, so I did it right. What are you talking about? Maybe, maybe I forgot the parentheses. I did it right. I did it right the first time. What do you mean? Said as soon as you hit that door, I'ma put you down on the floor. Baby, touch that bed. Baby, back up, baby, what you said. Oh, the V squared on the liters. I don't know what he's talking about. As far as I know, I'm right. Everything's right though. You see that one times 0.0821 times 300 times 10 minus 0.0318. Then 1, and then we have 1 squared. 1 times 1.36 squared. Oh, maybe I need the parentheses again. I need parentheses. Wait, so I did it right. I did everything right. It still shows here 2.45. 2.45, 2.4523. So there's a 2 here, so I can round it up. So how the hell did it... What? Let me just... So I get 2.47 here. Oh, because of the decimals. You're not supposed to put decimals on. So, okay. So we were right the first time. Except you're not supposed to do this. N times a 13.36. This is 1.36. I'll do another problem. I did it right the first time. What are you talking about? It was only trying to find it's because ChatGPT rounded up. I mean rounded off. That's how we got the answer. Because mine came out like 2.45. Do you know how nitpicky they get with all the rounded numbers? So you have a... Let me just... So we have a gas. Number 2 is find the pressure of a gas contains 2.00 moles of gas and occupies 5.00 liters of fuel. So P is equal to nRT per v minus nb minus a squared n squared a over b squared. Oh. O'clock, home alone, chasing you. Can you come over? Let me just pause this. B squared is 5.00 squared. Yeah. Let me just pause this. Right, so we're gonna put that in a calculator, scientific calculator. Just follow along. Eight two one. 821 times 350 divided by 5.00 times 0.391. I mean minus times minus. Minus 2 times 1.32 squared minus 1.39 over 5.00 squared. Which is equal to 11.36 atmospheres. It says here 11.36 atmospheres. I know I'm doing this right. As far as I know. I don't know what you're on. I don't know what this guy is on. What but Desmos is on 5.00 squared 0.0391 2.00 0.820821. This is the constant n, and is mole 2.00 moles 350K. V minus NB 5.00. So maybe, okay, maybe they're rounding it off. Five point zero zero, 0.821. What is the constant reading? 821. Yeah. Two squared times 1.39 divided by 5 squared. Yeah, it still says 0.36. I'm not sure about that. Maybe it's 0.025 here. Still not it. I don't know why it is that way. Still says 11.21. But why? It's 11.34 here. Maybe they're rounding it off. So maybe we have 11.57, and then if you take off everything, is 11.57. Two squared times 1.39. Oh, maybe. This is the problem. 2 squared. That's the problem. Why did I put that there? That's so stupid. So we have 1.39 squared. Probably squared. Just a liter squared here. This is the liter squared here. What's our H1? still not working. I must be doing something wrong. I really must be doing something wrong. I did every single thing correct though. I have n here 10 times r 0.0801 times 350. 350 is the temperature. Divided by v, which is 5 point v minus m v, which is here 0.0391 minus 1.39 over 5 squared. How do you solve for reduction? What? Why is there 2 here? So you still have to times it with the moles. What? Earlier you didn't times it with the moles, or am I seeing things? Am I seeing things? I probably am, but what? You didn't times it with the moles earlier? 2.00 squared. So it's still the same thing. It's still the same thing. What? So I have to do this one by one. I have to do this one by one. I'm not doing that. I have to round off so many stuff. Let me try this. Let me actually try this and see for myself. What the hell? What are you talking about? 57.47. 49218. 2 times 0.0391, which is divided by 4.9218. See, now that's where you're wrong. That is where you're wrong, ChatGPT. Because it says you're 11.67 and you say it's 11.675. That is where you're wrong. It's 11 point. Oh my god, ChatGPT is so wrong, dog. I did everything right. Either way, that's how you solve for this. Let me just check my actual notes, because ChatGPT is really tripping right now. Apparently, ChatGPT can't do simple math. Simple 0.0438. Yeah, so the method I used was right. ChatGPT just refuses to give me a correct answer. But the method here, you see here, the method you see here is right. Don't believe what ChatGPT says. S2 squared. By the way, sorry for my illegible writing. I just really can't control it that much with my mouse. It's really my mouse is really sensitive, high in sensitivity. Let me just check my notes. This topic. Yeah, so that's basically it. Thank you guys for watching. That's Van der Waals equation.